Hi everyone, welcome to Math Academy. What I am going to talk about today is solving a problem with radical expressions. There is the cumulative sum of radicals that under each of radicals there are three terms in a special order. So we can say we have a finite series. On the left hand side and on the right hand side we have n minus 1 over n, and we have to solve this equation for n. To find relationship between all the radicals I should introduce a variable. I choose x, and so I can write each of the radicals as square root of 1 plus 1 over x squared plus 1 over x plus 1 squared. So I can write the summation of this radical as x goes from 1 to 99. As you can see, there are three terms on the radicals, and to add these terms we need a common denominator. So we should multiply top and bottom of each terms by the denominator of the other terms. X squared multiply 1 multiply x plus 1 squared is common denominator. This can be written as x times x plus 1 squared, or x squared plus x to the power 2. In the next step, look at these terms. This can be expanded using this identity. A plus b squared equals a squared plus 2 times ab plus b squared. X squared and this x squared is going to be 2 times x squared, and I can factor out 2 from these two terms. Now, in the numerator of this fraction, I have an algebraic expression that is same as this identity. A squared plus 2 times ab plus b squared equals a plus b squared, where a equals x squared plus x and b equals 1. By using this standard algebraic identity, I get a perfect square on the radicals, and so it can have its square root pulled out of the radical. Now I can break down this fraction that becomes x squared plus x over x squared plus x plus 1 over x squared plus x. the first fraction becomes 1, and I get 1 plus 1 over x squared plus x. Look at the second fraction that can be broken down in partial fraction. The denominator of this fraction has two linear factors. They are x and x plus 1. So I can write the partial fraction for each factors obtained with the variables in the numerator, and I say them a and b. To find the values of a and b, multiply the whole equation by the denominator of this fraction. This equation is going to be 1 equals a times x plus 1 plus b times x. Then I can take out x and I get 1 equals a plus b times x plus a. Now we can evaluate the coefficient of x and the constants. From this equation, I can write a plus b equals 0 and a equals 1. From this, I can say a equals negative b, and since a equals 1, b is going to be negative 1. Now I substitute these values in this equation. In the next step, I can replace this fraction by these two fractions. And I get simpler fraction in series. Now we need to start by expanding this series. By replacing x by 1, 2, 3 to 99, we will have 99 terms that they have three, each of them has 3 terms. For example, if I replace x by 1, I get 3 terms, 1 plus 1 over 1 minus 1 over 2. If I replace x by 2, I get 1 plus 1 over 2 minus 1 over 3. If I replace 3, I get 1 plus 1 over 3 minus 1 over 4, and if I replace x by 99, I get 1 plus 1 over 99 minus 1 over 100. That is equal to n minus 1 over n. Now, as you can see, we have 99, 1, and to add all the ones, we can write 99 times 1. Also, as you can see, negative 1 over 2 and 1 over 2 is going to be cancel out each other, and also negative 1 over 3 and 1 over 3 is going to be cancel out each other. The intermediate terms cancel out each other, leaving only the initial term and the last terms. We have 99 times 1 plus 1 minus 1 over 100 equals n minus 1 over n. This is a simple equation, and 99 times 1 plus 1 equals to 100. And by solving this equation, I can say the values of n are going to be 100 and negative 1 over 100. Thank you for watching this video. Please don't forget subscribe, like, and comment.